everyone one by one, up from the lower part of the stream to the upper part of the stream. Next, so then this is the same big boulder that we saw a couple of slides ago, where we basically have to use some kind of rope to get from the bottom of the boulder, almost 10 meters high boulder, to the top of it. Next one. Sometimes we can also use roots. If roots are very sturdy and they are not rotten, and they have to be predictable, of course, before you climb up. You can use roots near the stream again, on top of the waterfalls. Many of the trees you will see kind of put their roots down towards the bottom of the fall or the bottom of the stream to basically absorb water during the dry season. Next one. So this is, up till here it was all about valleys, pools, streams, kind of the things that you encounter, gorgeous when you walk along the lowest point within these mountain ranges. Now let's take a look at the opposite, the inverted V, the inverted U here, the ridges. So ridges again, I think here we have a clear view, right? The ridge is like the highest point. Any rainfall or people who walk left, right, you're basically getting down. So this is the highest point in your terrain here, so keep that in mind. That is something that you can clearly identify on a topographic map, these ridges. It's important because the ridge is a very important thing to get across a mountain range. Most of the time you're going to follow either ridges or valleys, so you will have to identify these type of things on a contour map or a topographic map. Next. So again, same ridge, right? You can see a ridge doesn't have to be continuous. Sometimes it can be flat, sometimes it can go steep, then again flat, up, down, left, right. So ridges can be very kind of non-linear, that you go left, right, steep, slower gradient. But it's most of the time it's quite gradual and it's kind of convenient to walk on this. Ridges again are mostly suitable after, you can see the season here, post-monsoon. Once you go somewhere January, February, when it becomes sunny, close to the summer, ridges will become very hot, after 10 o'clock in the morning, 11 o'clock in the morning. You will also see this green landscape completely gets transformed in like golden dry grass as no more water falls down and the sun beats down on you. So in that summer season, typically you're going to stay inside the valleys while trekking and navigating. Okay, next one. Here again you can see another ridge, right? So sometimes the ridges can be bumpy also. Next one. So here you see a nice example of a saddle, two small peaks, and in between you can see, if you follow the ridge, the lowest point is your saddle. Next one. And as somebody correctly said, right, why don't we walk on the slopes? Why do we walk in either we walk on the valleys down there, or we walk on the ridges, which will be somewhere on top here. We do that because it's kind of gradual, it's kind of flat. If you walk on the slopes between the valleys and the ridges, it becomes tricky. It's quite steep and you don't have any flat space. You're always going to walk on a gradient, so it's going to be tricky. You'll have to make sure that you don't bang down 200 meters back into the valley. But most of the times, unless we have to climb across gorgeous waterfalls, vertical drops, you're not going to get onto the slopes. And then finally peaks, right? Peaks, many people go trekking to reach the peak, to have that satisfaction, that confidence level building, and that amazing view, that top of the earth feeling. Once you're on the peak, actually the whole landscape is below you, and it's like an amazing feeling to be able to, after one day of climbing, reach the peak and then look around you and have amazing views all around you. So that's, here again you can see people following long ridge to actually basically eventually reach the peak, where the ridge from one side meets the ridge to the other side. Okay, so now let's take a look at maps. This will be a little more technical, but I think we need to go through this. Anyone serious on planning a trail or understanding kind of a place needs to kind of look at topographic maps. So let's just take a look at this. So I've copy-pasted something here. Any questions so far? I don't want to rush too quickly, or so. Any questions, doubts so far? Is it interesting a little, I hope? Everyone is silent, might be a boring silence or a post-lunch nap silence. Again, I think maybe we can start passing some juice so that people stay alive. Yeah. So any questions? Nobody? I mean, this is like most silent group we had so far, I think. No doubts? Okay. So now let's take a look at maps. So copy-paste, Wikipedia, a lot of maths and theory. But we need to take a look at this, guys. So what is a topographic map? A topographic map is actually a projection of contour lines. So let's take a look at this picture. You forget about this mathematical definition. So this peak you can imagine, right? You got a peak here. You had a steep side on the west. You got a less steep slope on the east, on the right. Right. So one obvious way to climb on this peak will be to go from the right side, not from the left side. The left side will be too steep. So what is a topographic map? Actually, a topographic map is actually a two-dimensional projection or kind of picture, right? Projection of like a 3D relief, you can say. So basically, a topographic map is a combination of contour lines. What is a contour line? A contour line is a line. If you would walk along this line, actually you would walk at the same altitude. The contour line indicates one kind of area which has the same altitude. So for example, if one block here, one step says 20 meters, right? When I say 20 meters, I mean 20 meters vertical increase in altitude, right? So every contour line here would basically point to an increase. And normally you can't see any good ridges here. A normal view, here actually you have a ridge. A ridge is actually again opposite of the valley, so where the valley is an inverted view, a ridge is actually a normal view. Again, going from the bottom to top, right? If you go from the top to the bottom, it's reversed. But here you can see a U, right? So if we go to the next picture, I think, next one. So I'll show you one by one. So here you can see a picture in reality. This is a peak. This one, that ridge again, which we have seen. So here somewhere you have a peak, and here you have the corresponding topographic map of that peak. I think this will give you a good correlation. So next couple of slides are going to correlate peaks, valleys, ridges. Just a second, Google, let me explain one by one. So how do you recognize a peak on a topographic map? Any idea how you would recognize like a highest point? Yeah, indeed, it's kind of an inner circle, right? So here you, first of all, let me explain you, right? The thick lines here, the darker lines, the thicker lines, the black lines are like increases in 100 meters. The smaller lines are increases in 20 meters. So every 4 small lines you get to a big line. So if you walk along this line, you would walk flat at an altitude of 600 meters, here at 700, 800, 900, 1000. The peak is somewhere 1300 and another 2 lines, so 1340 meter altitude. And what you can clearly see here is, right, it's actually like you have like 3 peaks. I mean, the terrain is always very rough, right? It's never like a single peak or like a single ridge or a single valley. It will be like a chaotic combination of ridges and peaks and valleys. So, but if you just look at the small peak, what is the definition of a peak? A peak is the highest point, so no matter where you walk away from the peak, whether you go east, south, west or north, you're gonna start going to lower altitudes, right? So if you go here, you go from 1300 to 1200 here, you can see the line. If you go to the east again, you're going very steeply down. You can see it's very close to each other. So here, this side and this side is gonna be very steep, not the right way to climb to this peak. And if you go north again, you go slowly down, 1200, 1100, and here again, you're getting down to lower altitudes. So a peak is actually easily identifiable on a topographic map as inner circles, basically. At the highest points, the inner circle, the highest altitude. As you walk away from the peak, you will go to lower elevations. So in this case, what would be the right way to go to this peak? The easiest way to climb this peak? Looking at the contour map again. And so from which side, north, east, west, south, would we approach this peak? North, why? Yeah, indeed, so northwest, either you can actually go straight north or you can go northwest, because the spacing between the contour lines, the contour is your increase in altitude. Every little line here is 20 meters. Just imagine it, this is probably like, I guess, 6 meters. 20 meters is like 3.5 times this. So every line here corresponds to 3 times the height of this roof. So if you would go here, it would say you would immediately drop from, say, 1300, you're getting down here almost, I guess, more than 800 meters or 1 kilometer steep drop. So this will always be like a vertical ridge. Here it's also quite steep. Here it's like a little medium, but the easiest way indeed is to go along this kind of, this will be a ridge actually. Again, looking at the shape, this will be exactly like a ridge. Okay, let's take a look at the next one. So here we have a valley. So this is a valley, right? A V-shaped thing. So you walk along the lowest place in the mountain range. If you go to the left, you start climbing up. If you go to the right, you start climbing up. Same thing you can see easily on the contour maps. So this is going to be the base of your valley, the bottom of your in the stream or the lowest point in the valley. As you walk away from the center of the valley, you go to the right and you start climbing 400, 500, 600 meters. As you go to the left side also, you start climbing up. I hope everyone can clearly see that. I mean, identifying streams on a contour map is again like an important, basic kind of concept. So stream is the lowest point. If you go left or right of the stream, you're gonna start climbing up. And a stream you can recognize again from upstream to downstream as a U shape, or from downstream to upstream as an inverted U. Next one then. So the opposite of a valley next is a ridge. Yeah, please.
How to see? We are seeing that it is in a valley. How to find that there would be a stream, right? See, when I am.
Yeah, I mean indeed. So that there will be water.
I might assume that there will be some water, right?
Yeah, so indeed. So very good question. So we have a valley here. Valley is basically used for draining water when it rains during the monsoon. But in general, how do we know that there will be water there? Which is one of the key questions for any organizers in CTC to, before you take 20 people on this and cross this valley maybe of 15 kilometers, you want to be sure that there's some water there, otherwise you're going to be in trouble soon walking in this kind of tropical climates on these boulders with quite a bit of load on your back. People are going to consume a lot of water. There's a lot of dehydration happening. You're easily going to drink 4 or 5 liters of water per day. So one very important question is there water in that valley at that time of year? So that question is going to depend on several factors. I mean, I mean, can you help me a little bit? What would be related to the probability of water here? Give me, say, 5 different things that would point whether there will be water there or no water in this valley. One at a time. Steep of the valley means slow, but I mean whether it's like a vertical here or whether it's like slopey doesn't matter, I guess, right? For water.
A lot of vegetation or uneven tracks.
Yeah, indeed. Yeah, you can practically look at there's a lot of fresh green, light green vegetation that will point to water. Fresh animal tracks again will point to water. But what else? I mean, what would be determine whether there's water there?
Season of course.
Season definitely, right? Post-monsoon or midsummer will make a lot of difference. What else?
There is no vegetation on the street.
Vegetation again, same thing indeed. When it's all dry or whether it's like fresh green, then fresh green typically points to water. What else? Altitude, yeah. So if this stream is, I mean, this valley is close to the peaks. I mean, the beginning of the valley, obviously the amount of water that has been collected at that point is going to be much less than where the stream exits the mountain range, because there you'll have a lot of water. What else will determine? Remember one of the first slides that I saw, whether you will find water or not. Any other ideas? A lot of factors that it's a complex formula, so it's not always easy for even the organizers to predict. Any idea what will give you water or no water over there? No, I mean that is all animal life. You can indeed look at indirect signals, but what determines the presence of water there? That's what I mean. What determines the presence of accessibility of water there? Hey, obviously, season is one thing, but definitely another one is recent rains, obviously, right? So if it rains recently here, it's also going to definitely refill the valley. Another very important thing that, again, you can clearly see on the topographic map is how much part of this mountain range is drained by this valley. Some valleys might just drain like a small piece, like say 3 square kilometers. Some canyons or valleys, here you can actually see it's like a pretty deep one, so it's likely to kind of drain like maybe 40 square kilometers. So even though it might not have rained for the last 2 months, there might still be water there, because any water that has fallen down in the last 2 months hey, you can imagine some water that falls down here in the monsoon. It might take a little bit of time, right, to slowly trickle down through many crevices and rocks here to kind of reach the stream, and then again slowly trickle down. So you get a kind of a delayed effect. It's not that rain gets flushed out the next day. Water keeps running for weeks and months sometimes, depending on how long it takes for the water to kind of get through all these small crevices. And then of course another very important fact will be how much rubble is there in this valley. There are a lot of boulders and rubble there. There might be water, but the water might not be accessible. It might be like 2 meters below you on these flat riverbeds. Another very important thing I would say is typically if the stream is pretty flat, so the amount of rubble can sometimes be more, right? Because if it's like flat, any rubble that falls down stays there. While if you have a stream like a slopey stream, like a waterfall or like a stepwise kind of inclination along the stream, typically the stream will be freed of rubble and boulders and rocks because it will always come down to the bottom of the fall or the bottom of actually where the stream becomes flat. So sometimes when you don't find any water on a flat stream, suddenly when the stream starts going up, the solid rock will pop up to the visible eye, and typically the water will start running there. Okay, any other questions? That was an excellent question. Can we pass some juice to the public? Some of the volunteers, I think some of you might be getting thirsty. Keep refilling, we have a lot of time. We have biscuits there, keep mixing with water and just pass it on. Next one, the ridge. So ridge is actually the opposite. So ridge is the highest point. Highest point means you can kind of see here, if you follow these U shapes, that will be the ridge. This is the ridge. Why? Because if I go left, again I start going down. If I go right, I start going down, right? I'm at 600 here when I step. I'm at 600 meter here. When I step down on the left side, I'm gonna get down 500, 400. If I step to the right side of the 600 meter altitude, bang, I'm gonna get down to 500, 400. So like an inverted U basically gives you a ridge if you go from base to top, and stepping left or right is gonna get you onto the slope, and it becomes a bit more difficult definitely more difficult to walk here, very slopey compared to on top of the ridge. Ridges again, it always leads to the peak, the inner circles, the highest point in the terrain. Okay, next one. Now, so here a saddle. Here you can see like a saddle in Nagari, 2 peaks. Actually there are 3 peaks, one is here and there. And in between the 3 peaks you have 2 saddles. So you can see here the peaks are again the inner circles. Here you have a circle, there you have an inner circle. Here you have another peak, 900 meter peak, 700 meter peak, 620, 40, 640 meter peak. So if you follow the ridge from peak to peak, you can see that initially you're going down. You're going from 900 to 800, 700, 600. Then you come to the lowest point, which is the saddle. And so you walk down from the peak to the saddle, lowest point. And as you cross the saddle, again, you're cutting inside. You're going to inverted U's. So you're basically going up. So from 600, 500, 600, you're going back to 700. Then again, over the peak, you're cutting down, and then again, you're going like all U's or inverted U's, whatever you call it, pointing to each other. So here you have a valley, and here you have a ridge. Here you have a valley almost, and here you have a ridge. So it's like an X structure on the contour map. Okay. So 2 saddles there of Nagari. Yeah, so let's take a look at this map. I'm just going to talk 1 minute about this because this is important. So this is like a real topographic map. So whatever you have seen till now, it's like a Google terrain map, which is pretty naked, pretty plain. It just contains contour lines, nothing much else. Like if you look at other sources, like real topographic maps, like say the survey of India, or the Soviet army or American army maps, as we'll see a little later. So no, a map looks a little bit like this. You'll have also those contour lines. Again, you can easily find the peaks. You can find the peaks here, you can find the peak there in a circle, so highest point. Right, and then you can also see this cut here. This is basically a valley to where the water will drain. So any water that falls on the right side of this peak is going to settle down to the valley. Once it reaches the valley lowest point, it's going to exit and follow the stream basically. can see a stream there, and then you can also see some kind of ridges here. You can see some kind of ridges here. Different ridges that lead you to the peak. So if you look at any map, there are like 4 or 5 important things that you have to take into account. This is a little more technical, but I want to cover this. This is important. So first of all is the scale of the map, obviously, right? This piece of paper or this bitmap on your computer corresponds to what actually? Is this like 1 kilometer wide, or is this like 10 kilometer wide? So every map needs a proper scale, so that you understand. In this case, from here to here seems to be 1,000 meters. So this is 1 kilometer, right? So it gives you a reference point, a scale of the map. Another thing that is required for a map to be useful is you can see some Mount Morsi here, Great Peak. So they have given some names, but okay, if you look at this map and you're not familiar, you don't have a clue where this is, right? So this could be somewhere in North America, this could be maybe in the Himalayas, this could be in China somewhere. So you actually need to position this map, what we call geo-reference this map. So you need to kind of determine or fix, say, what is the exact, in addition to the scale of the map, what is the exact location of this place. So that is going to be indicated by these things. So you will have, horizontally, you will have what we call a longitude. So here you have something called 5 degrees, 85 minutes and 0 seconds east. And so as you go, here we go to from 85 minutes to 86 minutes, 87, 88 minutes. So every line here corresponds to a minute. We'll talk a little about latitudes, longitudes, degrees, minutes and seconds in a while. In many cases, the map is not going to indicate you meters or miles. It's going to indicate how many seconds or how many minutes is covered in a certain map. So horizontally, we have what we call longitudes, east and west. Vertically in the map, the vertical position will be indicated by what we call the latitude. Latitude is north above the equator and will be south below the equator. So here again we have degrees, minutes, and then seconds. So that's an important thing, the scale, the position indicated by latitudes and longitudes. Another important thing will be this one. So your map is going to point, as some of you might remember from geography in school, it's going to point to the north, right? All the maps have the north on top. So when you're going to use this map for navigation in the field, you would say, okay, here is my compass. My compass points to the north, the map points to the north, so you can kind of correlate both. But you have to be very careful, because the north that is going to be shown on by your compass is what we call the magnetic north. The top of a map is what we call the true north. So in both, depending on which place on the earth you are, there is a difference, there is a number of degrees. So in this case it's 14 degrees difference between the true north indicated by the map and the magnetic north, right, indicated by your magnetic needle of your compass. So be aware of that. I mean, if you're looking at your compass north, it's not going to be exactly the north indicated by this map. So these are a couple of important things that you will have with every map. Next one.
Excuse me, sir.
Yeah.
Will you please explain that compass thing once again?
Yeah, so the map points to the north. This is what we call north. We have east to the right, we have west to the left, and we have south down, right? 4 directions. So, right, so a map is used for navigation, for finding your way in a place. So, finding your way, you will typically use a GPS, or in the old times, many people still do, they use a compass. A compass is basically, it has a magnetic needle which is going to point, which is going to be bended by the magnetic field of planet Earth, right? So, and the magnetic field is not pointing straight to the north. It's going to actually be bent. It's going to be a little bent. So depending where you are, the needle is not exactly going to show you the North Pole. It's not exactly going to go to the North Pole. It will be aligned according to the magnetic field around planet Earth. So what I'm saying is that the North Pole, the true north indicated by this map, so this direction here is true north, is like the North Pole. That is not going to correspond to the compass north. If your compass points, your needle points to north on your compass, it is actually the magnetic north. Because your needle is I mean, magnetic lines basically do not go straight to the North Pole, they are bended. So depending on where you are in India, on the east or the west, there will be less or more bend. So your needle is not exactly going to point to the true north, basically. So what I'm trying to say is, if you use your compass, you go straight north with this compass. You're not going to go straight north here. You're going to go like to the magnetic north. So you might be going actually like in this case, you're going to go 14 degrees away from the true north. That's a little bit what it means. I'm not sure how clear that is, but I probably need to show you a picture of the magnetic. There's a nice screenshot actually. We have an internet connection a bit later. I'll show you how the magnetic north, in the magnetic lines that basically the magnetic needle will align to, how it kind of bends around the Earth. Okay, and any other question?
Yeah, does the degree differs based on the places?
Yeah, before I can show. I actually had a beautiful shot of the United States. East coast, west coast, in the middle of the United States, you will have a different magnetic north. The magnetic lines are a little bent differently. I mean, it's difficult to explain a bit, but I mean, in one place in the US it will be exactly the same. It will be pointing straight, but at the east or west coast, it's actually quite strong. It would be like 20 degrees away from the true north.
Does all the map indicates the magnetic north?
Should be right, because I mean, either you need it on the map, or you need to figure out somewhere on the internet, like how is the magnetic field of the Earth, so that you know, say in Europe, in Belgium, or in China, in India, what is the direction of the magnetic line, so that you know your needle of your compass is not going to go true north, but it's going to go a little, it's bended to the left or bended to the right. So any calculation you do here in bearing, I mean in directions, you'll have to make this small correction here. And then we also have this thing, I'm not too familiar with this, is actually your projection system. I think it has something to do with